Okay, so what we're going to do here is we're going to look at the range equation, and we're going to use it to help us find the angle. And so our range equation, and this is for the arrow problem, I don't remember the problem number, but the range equation says I take the velocity squared and I multiply it by sine of 2 times my angle, and I divide it by the acceleration due to gravity. Now, in our problem, we have some arrow being fired at a target. And the target we'll give the target a bullseye type pattern. The target is some distance away, a range. And so the range equation said I cover that distance given these parameters. And so I have to fire this at some angle to make sure that gravity compensates for it and it smacks and hits right dead middle in the target. And so if we know the distance, we know the angle. And again, for lack of better terms, I'll say this is 75 meters. And this is firing at 35 meters per second. And so what I want to do is I want to solve for theta. So to isolate theta, I'm going to multiply both sides by g. And then I'm going to divide both sides by v naught squared. And I'm going to switch my sides around so I can operate, because I want to isolate theta, so I'm just going to switch my sides. There's nothing wrong with that, and equality holds either way. And back when we were introducing the different sine functions, we said, hey, these things have inverses, and we use the tangent inverse to find the angle. Well, here we're going to use the sine inverse. So if I take the inverse function of sine, whatever I do to one side, I have to do to the other. And so inverse functions cancel out. That leaves me with 2 theta is equal to the sine of -1 over g of r over v naught squared. And if I divide both sides by 2, that becomes my formula that I need to find theta. Well, now I can enter everything in the calculator. So we're going to say g is 9.8 meters per second squared. R was 75 meters in my setup here. Again, refer to your problem. And v naught was 35 meters per second. So if I put this in on my calculator, let's switch over to here. I'm going to start with the second key, and then I'm going to hit sine inverse. Okay. And then I had 9.8, because I had g times r, which was 75, divided by the 35 meters squared. I'm going to close my parentheses and divide that result by 2. And I get 18.43 degrees. And so that's how we isolate an angle in any of the equations that we use. We can isolate the angle back out.